Today we're going to continue to talk about sections 3.5 and 3.6, which is the multiplying radicals and dividing radicals. On the last video I showed you how to multiply radicals, and today what we're going to do is divide radicals. And we did numbers 1 and 2 earlier, so what we're going to do today is we're going to divide the square root of 80 by the square root of 5. Well, all that is dividing 80 by 5 and taking that square root. Well, if you do 80 divided by 5, I think you might get 16. And the square root of 16 is just equal to 4. So you might have been tempted to simplify that square root of 80 first and then divide it by the square root of 5, but it would be a little bit easier if you just divided the radicands. Just like when you multiply the radicands, same thing when you divide. On number 4, what you're going to do is divide 48 by 2, divide the outsides, and you get 24. And then you can divide the insides. This can be one big radical, and it can be 8 over 2, which is 4. So this is like 24 that we got here times the square root of 4. And the square root of 4 is just 2. So this is 24 times 2, which is equal to 48. And so that would be the final answer on that question, number 4. There's some other examples down at the bottom. This is on page 5 of your notes if you haven't gotten that yet. But down at the bottom of page 5, there are 4 questions that we're going to go over. And we're going to approach them in the same way. We're going to divide the outsides. 40 divided by 2, we're going to cancel that down to 20. And 20 divided by 5, again, is 4. So what this is 20 times the square root of 4. And the square root of 4 is just 2. So this is 20 times 2, and the final answer is 40. So there's the first one. On number 2, if you have a square, now this is kind of going the other way. Before we had 2 square roots, one in the top and one on the bottom. In this one we have one great big square root, and there's a fraction underneath it. So this is actually just like the square root of 18 divided by the square root of 25. Well, I'm doing that because 18 over 25 can't be reduced at all. So what we can do is we can reduce 18 down. The square root of 18 is 9 times 2. And the square root of 25, well, 25 is a perfect square, so you're just going to take that square root and get a 5. And that square root of 9 can be taken outside and be called 3. So this final answer is 3 times the square root of 2 on the top over 5 on the bottom. Now if this 3 and 5 could have been reduced, like if this were 3 and 6, or if this was 5 and 25, you could have reduced that down, but 3 over 5 doesn't reduce, so that's the end of that problem. On number 3, you have a binomial on the top and a monomial on the bottom. Well, what that means is each one of these terms of the binomial is going to be divided by 4. So we're really going to split this up into 2 fractions. We're going to split it up into 12 over 4, and then you're going to add to that 4 square root of 2 over 4. So let's just rewrite that, both of them being divided out by 4. 12 divided by 4 plus 4 square root of 2 over 4. See that? 2 fractions come out of 1. And we just simplify each fraction down. 12 divided by 4 is just 3. And 4's on the outside of the radicals. They can cancel out, and you're left with 3 plus the square root of 2. And they can't be combined because one is a radical and one is not. And then this other one, 18 over 3, we're going to do just like we did before. 18 over 3, make sure you divide both parts of that binomial by the 3. So you're going to have plus the square root of 72 all over 3. Well, 18 over 3, that's just a 6. Now 72 can be broken down. 72 has a perfect square of 36, among other things, but the biggest one is 36. So you're going to take the square root of that 36, you're going to pull it outside, and you're going to call it 6. So I'm just going to do that right here, save a little bit of writing. So the square root of 36 is 6 on the outside over 3. And then 6 over 3, well, that reduces down to 2 over 1. So what we have left in the end is, don't forget to write that 6. And then we're going to add to that 2 times the square root of 2 and it was all over 1, but you don't have to write that. And please do not add that 6 and 2 together. So many people like to, because you've got the 6 and the 2 right next to each other, you might want to call that 8, but don't do that because this 2 is part of this radical. So please write that note down. Don't add 6 plus 2, because that 2 is part of that radical, and you can't add a non-radical to a radical. Moving over to page 6 on the notes, we're going to have a lot of problems here, but I'm only going to go over the odd problems. And what we're going to do is we're going to review the fact that you can't have a radical in the denominator. So we're going to do something called rationalize the denominator, which just means get that radical out of there. And if you remember previously, what we're going to do is we're going to multiply this by 1. And 1 is in the form of, just hold on a second. The square root of 7y over the square root of 7y. And we're going to go through a lot of that in a later video. So what we're going to do here is we're just going to multiply straight across. And straight across says 7 times the square root of 7y is 7 times the square root of 7y on the top. Square root of 7y times the square root of 7y is the square root of 49y squared. Because remember, you multiply the 7's and you multiply the y's together. So what we're going to do now is we're going to take the square root of 49 and we're going to call it 7, and we're going to take the square root of y squared and we're going to call it y. So down on the next line, the top is just going to be written as 7 times the square root of 7y, and on the bottom the square root of 49 is 7, and the square root of y squared is just y. And neither of those have a radical around them. So this 7 outside the radical can divide out with that 7 that's outside, it's not inside a radical. And what you have as a result is a square root of 7y all over y. So just as a little introduction to this, make sure you don't have a radical in the denominator, because it's an improper fraction actually. Number 17, what we're going to do with 17 is you could take care of this a number of ways, but I think what I'm going to do is, because I have the numerator denominator, it looks like it can divide evenly, I'm just going to create one big fraction called the square root of 18c cubed on the top and a 9c on the bottom. So I'm going to make one fraction, or one fraction underneath the radical. And then you just divide 18 over 9 is 2, and c cubed over c is c squared. And now we have a perfect square. 2 is not a perfect square, but c squared is. So I'm going to circle that, and I'm going to move that outside the radical. The square root of c squared is c, and the square root of 2 stays underneath. So that would be that way. You could do it a number of different ways. I think that's the fastest though. On number 19, like I said, I'm doing the odd problems. What you have to do is you have to divide 3 square root of 10 by 3 square root of 5, and subtract from that 9 square root of 50 over 3 square root of 5. You're actually creating two fractions. So let's write that out. 3 square root of 10 over 3 square root of 5 minus 9 square root of 50 over 3 square root of 5. And then you can simplify that down. Those 3's will cancel, and you can create one big radical out of this, 10 divided by 5, which is 2. So the 3's go away, and you're just left with the square root of 2, 10 over 5. Over here, 9 divided by 3 is 3, and 50 divided by 5 is 10. So you can call that the square root of 2 minus the square root of 10. Don't combine those, because you can't combine unlike radicals. These would have to be equal to each other in order to be combined. The next one is number 21. Again, we have a binomial over a monomial, so we're going to split this up into the square root of 20 over the square root of 5 minus the square root of 5 over the square root of 5. Well, the square root of 20 over 5 is just like the square root of 20 over 5. 20 over 5 is 4. 5 over 5 is 1. So the square root of 4 is 2. The square root of 1 is 1. And 2 minus 1 is equal to 1. So that's your final answer for number 21. Number 23. Very similar problem. You're going to create two fractions out of this single fraction, the square root of 10 over the square root of 10, plus the square root of 15 over the square root of 10. Well, anything over itself is 1, so I'm just going to put a 1 there. They actually cancel each other out. Plus, now 15 over 10, you can call that 15 over 10, or you can reduce that down because 5 goes into each of them. The square root of 15 tenths reduces down to the square root of 3 over 2. But we don't want to have a fraction underneath that radical. So what we're going to do is we're going to multiply this by the square root of 2 over the square root of 2. And now we're going to get, we have to write that 1 again. The square root of 3 times the square root of 2. Remember, when you multiply radicals, well, I got to put a plus sign in there. When you multiply radicals, you're going to get the square root of 6. And underneath, the square root of 2 times the square root of 2 is the square root of 4, which is just a 2. So there would be that final answer, the square root of 6 over 2. And you're not supposed to have a radical in the denominator. That's why I just changed it like that. Number 25 is different because it's a cubed root, but it's kind of done the same way. Split it up into two fractions. You've got the cubed root of 27x cubed over the cubed root of 3x cubed, I think I have underneath there. And you're going to add to that the cubed root of 36x to the 5th over the cubed root of 3x to the 3rd. Well, we're just going to divide this. 27 divided by 3 is 9. X cubed over x cubed will cancel. This is, remember, this is really just like one big cubed root. So we're just going to take this as the cubed root of 9 because those x cubes will cancel underneath there. And over here, 36 divided by 3 is 12. And x to the 5th divided by x to the 3rd is x to the 2nd. And you have to write a little 3 in there too. So you have a cubed root of 9, which there's no perfect cube in 9, and there's no perfect cube in 12. So you have to leave it like that. Remember, these are not square roots, they're cubed roots. Number 27, if you have a 4th root and a 5th root, you can't create one big radical. So you're going to have to create, you're going to have to simplify the numerator down by itself and then the denominator. So since this is a 4th root on the top, we're going to split c to the 6 up into the c to the 4th, because those should match, times c to the 2nd. Just splitting that up so we can reduce that. And on the bottom, the 5th root of c to the 5th, well, those two match, and all you do is divide those. So the 5th root of c to the 5th is just a c. And on the top, we're going to reduce this down because the 4th root of c to the 4th is just going to be c. We'll move that on the outside. So we have c that we've moved outside times the 4th root of c squared, which we're not going to touch because 2 is smaller than 4. And then on the bottom, we have to rewrite that c. Well, a c on the outside cancels with that c, so the only thing we have left is the 4th root of c squared is our final answer. And now in this last one, we have a square root on top and a 4th root on the bottom, but we still have to create two fractions out of that. So we have the square root of 64 x to the 4th over the 4th root of x to the 6th. We'll have to treat those separately because this is not the same radical as that square root 4th root. And now we have a 4th root of 40x to the 6th all over the 4th root of x to the 6th. Now those two can reduce down because they both are 4th roots. On the top, The square root of 60, remember there's a little 2, invisible 2 here. 64 is a perfect square, and x to the 4th is a perfect square. So we'll take the square root of 64 and call it 8. We'll take the square root of x to the 4th and call it x squared. And on the bottom, we have to break that 4th root up of x to the 6th into x to the 4th times x to the 2nd. Remember, to get an x to the 6th, we have to add those exponents. And we're doing that so we can get that 4 and that 4 to match up. And now, since those are both 4th roots, we can actually cancel the x to the 6th out because they're both 4th roots and they're both x to the 6th. So we're left with the 4th root of 40. And I don't think there are any perfect fourths that will go into 40, because 2 to the 4th is 16, that doesn't go into 40, and 3 to the 4th is 81. So there's really no simplification here. But what we can do here is we can take the 4th root of x to the 4th, take it outside. I'm just going to cross it out and put it out here. The 4th root of x to the 4th is just an x. And now x is on the outside. This x is a factor. So remember, you can reduce factors down. So this x squared and this x will reduce down to an x, and that just cancels out totally. So what we have is on the top an 8x. On the bottom we have a 4th root of x squared, and to the right of that we have the 4th root of 40. And I'm not going to do anything more with that. You could rationalize that denominator, but I think that's just overkill for this question. So I'm going to just end it right there. Have a good night.